Welcome back. This is an overview on creating place-based 3D models. Designers and engineers have been using three-dimensional modeling for centuries. But up until the past few decades, 3D modeling was merely an artistic perspective drawn with pencil and paper. And although this is still a popular method for many design professionals in the beginning stages, with the ever-growing advances in computer technology, digital 3D modeling has a whole new capacity, including the concept of place-based 3D models. 3D models are used at all scales to represent schematic elements. Design professionals, architects, engineers, artists, and researchers all use 3D models to portray scaled-down perspectives of some element they are interested in visualizing or analyzing. These models can be static or dynamic. They can be exported as two-dimensional graphics, exported in a 3D digital environment, or even made into 3D physical models made of clay, styrofoam, or some other medium. Place-based 3D models allow users the capability of geolocating a 3D model into a geographic projected model. For example, a designer could model a building with a 3D software package like SketchUp, AutoCAD, or Revit, then geolocate it into a GIS like Google Earth or ArcGIS. Then visualize the model using a contextual approach. The advantage of creating a place-based model is the ability to visualize a concept in its final environmental or urban form. That is, once a model has been given a place, attributes such as bulk, aesthetics, and seasonal shade can be analyzed with respect to its surroundings. In other words, you can design a simple 3D model, then place it where you want it built and visualize it spatially. Now you can compare your model with other existing elements of the built environment. Let's say you're planning a transit-oriented development in a high-density urban area. This is a potential redevelopment site at Market and Euclid in southeast San Diego. You have some potential locations in mind, but you aren't sure if your concept will fit in with the surrounding communities. And you want to make sure your plan has community support before you hire any consultants or designers or do any more time-consuming community research. You could just make a simple model and geolocate it to several different locations, then print out different perspectives at each location to share with interested stakeholders. Geolocating a 3D model provides a contextual aerial perspective to help community members and decision makers decide if the proposed development has been appropriately located, decreasing the need to hire engineers, architects, or outside consultants in the early planning stages. This is a potential water treatment facility on the urban fringe. You may recognize it as the Glider Port parking lot just north of UCSD. You have a simple concept in mind, but how does it relate to its surroundings? There are a myriad of 3D software packages and geographic information systems that are best suited for different types of modeling and integration. Knowing which combination typically comes from hands-on experience. The scale of a 3D element and its spatial relationship to the rest of the world will often determine which combination of software integration might do the best job. As far as community-based research and planning is concerned, integrating SketchUp and Google Earth is a relatively user-friendly application integration with an appropriate scale, and it's free. I hope you've enjoyed the short introduction to creating place-based 3D models and that you can start applying this practice to your next community research or planning project.